Hello everyone, welcome to the numericals on induction motor. So let us solve some of the numericals related to the induction motor. So let us read out the question given here. An 8-pole alternator runs at 750 rpm, that is rotations per minute, and supplies power to a single pole 6-pole induction motor which runs at 970 rpm. What is the slip of the motor? So in this question, let us write down the given data first. Write down the given data. First, carefully read out the data. There is a 8-pole alternator which is running at 750 rpm, and this alternator is supplying power to the 6-pole induction motor. So we know that the motor is nothing but which converts the electrical energy into mechanical energy. The output of motor is mechanical energy. The input to the motor is electrical energy. This electrical energy input to the motor is given with the help of the generator, or which is also called as alternator. In turn, the input to this alternator is again mechanical. So here the data is given for the alternator and as well as the for motor. So an alternator which is running at 8-pole. So first let us write down the data given for alternator. Okay. The data given for alternator is there are 8 poles. P is equal to 8, and which is running at speed of 750 rpm. The alternator speed is given by ns, which is 750 rpm. Ns is nothing but the synchronous speed of the alternator. So these are the two data given for the alternator, and we know the relationship between the synchronous speed, number of poles, and frequency. It is 120. Ns is equal to 120 F by P. For motor, let us calculate the data given for motor. Let us write down the data given for motor. For motor, the number of poles are 6. This motor, number of poles are 6, and motor is running at speed of n. Motor speed is n. It is 970 rpm, and the question is we need to find out the slip of the induction motor. Slip. What do you mean by slip? It is the difference between the synchronous speed and the rotor speed with respect to the synchronous speed. The formula for slip is S is equal to ns minus n divided by ns. If you want this in terms of percentage, we need to multiply it by 100. So to calculate this ns, for motor n is given already. We need ns for the motor, but they have given ns for the alternator or generator. So the formula to calculate the ns for motor is again same, 120 F by P. So number of poles are known, frequency is not known. The frequency of the electrical supply which is given to the induction motor is not known. So we need to find out the frequency of the induction motor supply. To calculate the frequency of the induction motor supply to the induction motor, this data is given. Only to calculate the frequency of the supply, this data is given, that is alternator data is given. So ns is known, P is known. By using this formula, we need to calculate the frequency. The same frequency, the output of the alternator frequency is given as input to the induction motor. So let us calculate. Ns is equal to the frequency F is equal to, it is ns into P divided by 120. Rearranging this formula for F is equal to ns into P divided by 120. Ns is given, it is 750 into poles are 8 poles divided by 120. So upon calculating this, we will get this as 50 hertz. So the input frequency to the induction motor is 50 hertz. And now let us calculate the ns of motor. Ns of motor, that is synchronous speed. Synchronous speed of induction motor is nothing but it is the rotating magnetic field of the induction motor, which is given by the same formula 120 F by P. So 120 into frequency supply is 50 hertz divided by P is number of poles. Number of poles for induction motor is 6. Upon calculating this, we will get this as 1000 RPM. So the synchronous speed of the induction motor, that is the rotating magnetic field of the induction motor, is 1000 RPM. Magnetic field is rotating at 1000 RPM, which is called as synchronous speed. Now let us calculate the slip. Slip is equal to, the formula is simple, ns minus n divided by ns. Ns is 1000 minus n is given, it is 970 divided by 1000. So upon calculating, we will get this as 0.03. In terms of percentage of slip, it will be 3%. So this is the slip of the induction motor. Thank you. We will discuss some more problems in the next lectures.